Welcome guys as we do this problem. So I read the question given, this is what is the information given. Symmetric matrix A, it has eigenvalues, that is lambda 1 equals to 3, lambda 2 equals to 1. Eigenvector 4, that is corresponding to lambda 2 equals to 1 is 1, negative 1, and this is transposed. Determine matrix A and then eigenvector for lambda 1 which is equals to 3. And so guys, now we attempt this question. Guys, now for symmetric matrix, we shall have A, because we are said is we don't know the matrix, we can write AB and then BA. And this one comes about because the symmetric matrix, guys, is transpose is supposed to be the same, meaning that if I were to write the transpose of this, guys, it's going to be this row we convert it to column is going to come to, if it transpose that, this row becomes a column, it will be AB, and this row becomes the second column, it will now be BA. And so therefore guys, this is what we call the transpose matrix. Guys, now using this matrix, we now come and write what we call characteristic equation. And the characteristic equation is written like this. First of all, this is matrix A. Characteristic equation, guys, is written like, let me just write the word characteristic. It's supposed to be A minus lambda identity matrix equals to 0. That is, guys, the determinant of that will give us 0, where A is the matrix that we require. So guys, we go ahead and now use this equation. So we shall write A, B, here we have B, A. Now subtract lambda, and then we can write here the inverse, not the inverse, but the identity matrix, which is 1, 0, 0, 1. Guys, this comes to A, B, BA, now minus, guys, we can now multiply that. We have lambda, here we have 0, and then we have lambda there. So from there, guys, we come and now work out this, so that now guys, we are going to have that. This is A minus lambda. The other one we have A, and right here we have, this is actually B, minus 0 is B, and here guys we have B, here we have A minus lambda. So guys, this is what we are saying should come to 0. And so now we evaluate that by multiplying subtracting the minor product from the major product, that is the major diagonal product. And so guys, that one will come to this. So guys, this is what we have. I have multiplied A minus lambda, and I multiply again, that is with A minus lambda minus B squared. It comes to that. Then guys, I have come up to this place where I have converted this to look or to be a quadratic equation. It's actually a quadratic equation. But remember guys, we are given lambda 1 and lambda 2. So guys, what we are going to do, we are going to form a quadratic equation using lambda 1 and lambda 2. That is, we say lambda equals to 3 and lambda equals to 1. Guys, we already given that. And this is supposed to form such kind of an equation. And so guys, we form an equation, quadratic equation using that. And now guys, we equate to that equation. And this is how it is going to be. So guys, this is now the equation I have formed. This equation guys should now be equal to this equation. Because remember guys, the lambda we are talking here about here and the matrix will actually give us this quadratic equation. Because guys, as we said, we already know that and we know that, but we don't know the matrix. So what we are looking for is actually A and B. And so we equate those two equations. So this term, guys, is equals to this term. And so we shall have minus 2a. We can even leave out the minus because this is minus, this is minus. So we can even write both of them 2a. That is coefficient of lambda is equals to 4. And therefore, guys, a, this is negative 4. Can cancel the negatives. And this one now gives us a equals to 2. So, guys, we've been able to establish the value of a. We now go to the value of b. Guys, we use these constants. These are constant and they are equivalent to 3. So, this one is now going to be 3 is equals to a squared, which is now 4 minus b squared. Guys, we can now put 3 on this side and b on this side. So we have b squared is equals to now 4 minus 3, which is 1. Can now look for the square root on both sides. So that now, guys, we will have b is equals to 1. Indeed, it can also be equal to negative 1. So, guys, we can work with 1. So, b equals to 1. And therefore, we shall have our matrix, the one we asked about, will now be A. B is 1. So, we write it like that. So, guys, this is our matrix then. This is equals to A. Guys, now looking for the eigenvectors for lambda 1, which is 3. Guys, we use this equation. That is A vector x equals to lambda vector x like that. And so this is now going to be, we write A here, that is 2, 1, 1, 2, like that. Then we write x, y equals to lambda, which is 3, x, y, like that. So guys, from there now we just come and multiply row and column. We can even use just one of them, which is now 2x plus y. This one now gives us the first, that is 3 multiplied by x. And therefore we can say 2. We can bring 3x this side, so that now, guys, we shall have minus x, 2x minus 3x. And then on this other side we shall have minus y. And therefore the eigenvectors, guys, is going to be, first we write x. We have written x. As you can see, this can also be x is equals to y. Then we also write y in terms of x, and that is also x. Since this is vector, eigenvectors are ratios, this is now going to be 1 and 1. Written like that, guys. So this is our eigenvector corresponding to eigenvalue 3. Thank you guys for listening to me. Bye.